Welcome back, everyone, to the eCoreAcademy e-learning platform today. My name is AJay Raj, back with yet another geometry video for you all. Today's lesson is going to be a bit of a shorter lesson. It's all about the law of cosines, of course, continuing with our topic in our trigonometry unit. We're also going to be picking up our trigonometric functions with our oblique triangles, just I had referred to as our law of sines. I'm going to be showing you the law of cosines, and I'm going to correlate that as well. But before I jump into the meat of today's lesson, please make sure that you've already subscribed to our channel down below and hit that like button as well on this video, as well as clicking that post notification bell right next to that subscribe button so you don't miss out on any of our channel's latest uploads. Feel free to comment down below. Put down any of your feedback or any of your comments. It won't go unnoticed, of course. And any of your feedback or constructive feedback in the comments, we will try and implement in later videos to come. So all four of those things are greatly appreciated. As I was saying, our lesson topic for today is to discover what the law of cosines is and how it can be applied to triangles as well as other trigonometric functions. So if you take a look at my previous video, I strongly recommend that you go ahead and do that. It's the law of sines. And in the law of sines, I had talked to you about a trigonometric function in which can be applied to oblique triangles. So that's when we take our right triangle ratios and then we're going to apply it to oblique triangles as well. And I had involved a problem at the very beginning of that lesson, which I'm going to go over the solution to. I did alter the solution a bit. I'm going to be utilizing it more towards our video today here. One of our problems here today, I'm going to be showing you how to actually calculate that on a calculator, which you should already be familiar with. So don't worry, I will do that in today's video. I did not want to confuse you. If you haven't watched my previous video, I'll start fresh from this video. But we're going to show how to also differentiate between the law of cosines and the law of sines, and when not to utilize them, because they do conflict under certain circumstances. So I'm trying to make it as easy as possible, and I'm going to walk you through that as well. So let's jump right into it. So let's look at the development of the law of sines, law of cosines, all about the law of cosines. So it's the only trigonometric ratios can be used to calculate missing parts of right triangles. So your basic ratios such as sine, cosine, and tangent, not the laws, just those basic functions that you're going to input into your scientific calculator. Those functions are only going to be applicable to right triangles. But the law of cosines can be used for oblique triangles, likewise as the law of sines. And under specific circumstances, we will learn which formula is more convenient than the other. So this is an example of an oblique triangle. It's an improper triangle, one that does not have a 90-degree angle as shown here. And most of your cases that you're going to come across, of course, specifically in this topic, it's going to be referred to under your oblique triangles. When you're given your right triangles, it's much easier to solve for whether or not it comes from missing side lengths, missing angle measures. You already have those correlations. You automatically know what one angle of a right triangle is, 90 degrees. You have special types of right triangles. You already know how to easily calculate their side lengths with your sine ratios and trigonometric ratios and their inverses. And also, you know that it's a proper triangle because for area, it's going to be 1/2 of any given rectangle or square. So it's easily derived in that form. So it's much easier to compute with those. So obviously, law of sines and law of cosines are going to be a bit more complex applying with our irregular triangles. So let's move on. Applying the law of cosine. So we're going to describe the formula, formulate the formula, and I'm going to be putting into forms of relationships. Meaning, if you're given any equation, such as the equation y equals mx plus b, the equation of a line on a graph, you know that it's y equals mx plus b is in terms of y, meaning y equals mx plus b. You have the given value of y. However, you can always alter it, meaning you can alter it into a fact that b or negative b equals mx minus y. So you can always alter the given formula. It's going to stay consistent, but it's depending on what variable you're trying to look for, what variable you're looking for, and I'll describe that here. So the law of cosines formula is a formula which combines the Pythagorean theorem, which might not make any sense to you. It doesn't necessarily need to. This is just a formula you utilize from various trial and error. It does not have any origin or backup, but it does have proof, which is the law of cosines. So it's a mixture between the Pythagorean theorem. It's just a scrambling of all of them. So it's your Pythagorean theorem, your cosine ratio, and a specific relationship. So it's a larger formula, one that you will probably look forward to deriving in pre-calculus, but that's with different methods, and also you're going to be utilizing imaginary numbers as well. So we aren't there yet, but I will make sure that's in the next unit as well. So we have cosine ratio, Pythagorean theorem, and specific ratio, which basically is just a multiplication sequence between given sides and angles. And it can relate corresponding angles and sides together. So this isn't just for your given side. So what it does is, if you're looking for a given side length, it's going to utilize both, cosine of a given angle and a formula between the relationships of sides. Likewise, you can also discover the length of an angle. So this is applicable to any of the 6 given measurements on a triangle, all 3 angles and all 3 sides. And you can calculate the missing measurements, like I said, between both angles and side lengths. And of course, your proof is going to be your law of cosines. I'm sorry, your cosine ratio, your cosine function that you utilize with your right triangle. It's going to be the same properties, same similarities. Of course, this is your given oblique triangle. So that's when we're given, say for example, we're given at least one angle and one side. Once we're given at least one angle and one side, say for example, we're given A, and we know that it's adjacent over opposite, so maybe we're given the length of side B. That's 7 feet. We know that angle A is 30 degrees. Then we can complete the triangle, which is completing the triangle means I referred to it in my previous video, so complete the triangle. Complete triangle equals 3 sides and 3 angles. I just want to put in here, this is a verb, not an action, or not a call to action. This is a verb. So let's look at the formula part 1, and we're going to put this formula into terms of our given scenario. So I'm going to refer to the formula in its basic form, what it's normally given to, and this is in terms of A. So in terms of side A, and notice how I put side A as a lowercase. Remember, when we're referring to a triangle, your angle measure is always going to be capitalized, your vertices, but your side lengths are always going to be lowercase, and each angle is opposite to its given given same letter side, but their A and A are different, uppercase and lowercase, just to differentiate. So the formula is constant, but can be readjusted based off the values of focus, but it is proved by the cosine ratio. So as I was saying, you have 3 different forms in which you're going to alter this formula, and it's going to be constant depending on any given specific circumstance or specific situation. So let's look at this equation in its most organic form. You're most likely going to be referred to. It's most likely going to be referred to in aspects of A, your side A and angle A, but of course you have your side B, angle B, and side C and angle C. So we have side A and angle A, and the equation is A squared, which is of course A, B, and C lowercase are your side lengths, and of course A, capital B, capital C are your angles. So that's saying that A squared equals B squared plus C squared minus 2 times BC multiplied by cosine of A. So if we're given this triangle here, and just to answer the question that I had previously, what you're just going to do is, I had a sine problem put up there. All you're going to do for that equation is you're just going to multiply your sine function out through a calculator, because it's actually already simplified. So that's a question I was going to ask. Is it simplified or not? Yes, it's already simplified. So all you have to do is plug it into a calculator. No more writing methods needed. So looking at this triangle here, if we have A squared equals B squared plus C squared minus 2 times BC times cosine of A. So that's if we're looking for the length of side A. Let's assume that side A is going to be our X, our unknown, and we'll label side C as 7, side B as 8. And then angle A will be 30. So 30 degrees, let's be specific. Okay, 30 degrees. So we have A squared equals, so we're plugging in our value for B, or side length B. That's 8 squared plus C squared, which is going to be 7, minus 2 times BC, which is 8 and 7, so 8 times 7, all multiplied by the cosine of angle A, which is 30 degrees. Don't have to put degrees in there. So we'll start simplifying. So let's do our exponents first. So 8 squared is 64. 7 squared is 49. Minus, so 8 times 7 is 56. Negative 2 times 56 is going to be negative 112. So minus 112. And then we have cosine of 30. So we're going to leave that as such because we have to plug that into our calculator. But we're going to simplify this value here and then multiply by cosine of 30. So we have 64 plus 49 minus 112. So if we add those across, so 60 plus 40 is 100. 9 plus 4 is 13. So we have 113 minus 112 is going to be 1. So a squared equals 1 times cosine of 30. And we can simplify that to a squared equals cosine of 30. And then we're going to square root both sides of this equation. So a equals the square root of cosine of 30. And then the actual value is actually just going to round to 1. So that means x is approximately 1. Side length there is approximately 1. All right, let's move on. And just keep in mind, these are not drawn to scale. These triangles, they're most likely never going to be drawn to scale in geometry. When it comes to your complex figures, most likely not. When it comes to their angle measures and their side relativity, sometimes they are, but when it comes to simple functions, but more complex functions, most likely not. So the formula part 2, let's look at it in terms of side B and angle B. So this equation will correlate side B and angle B as they are always opposite from each other. So just keep that in mind. Same letter angles are always going to be opposite to the same letter sides. So this is b squared equals a squared plus c squared minus 2ac, but now it's cosine of b. So that's the new altercation that we have. That's the only new, altering that we have in our equation. So with this given triangle, if we keep our side lengths the same, let's alter the side lengths a bit. So we have b squared, so we're looking for a, c, and cosine of b. So we need side a, side c, and angle b. So let's say that a is 10, our c side is 8, and our angle is about 65 degrees. So if we were to calculate that out here, we have that b squared equals a squared plus c squared. So let's say that b squared equals 10 squared plus 8 squared minus 2 times AC, which is going to be 8 times 10, multiplied by cosine of B. I like to leave cosine of B or cosine of your angle last. It's much easier to compute with. All you're going to do is calculate it and then multiply it separately after simplifying these like terms here. So cosine of B is going to be 65. So cosine of 65, and we have B squared equals 100 plus 64 minus 2 times 80, of course, all multiplied by cosine of 65. And then afterwards, we have b squared equals 164 minus 60 times cosine of 65. And then b squared equals 104 times the cosine of 65. And then we're going to square root that. So we have b equals the square root of 104 times cosine of 65. And once you plug that into your calculator, you get that b is approximately 6.2. So we'll say b equals 6.2. All right, let's move on to our final part of the formula, part 3. In terms of side C, we're going to look at the equation in terms of side C, and angle C. So remember that this equation only applies to that of oblique triangles and their corresponding measurements. So just keep that in mind. Quick check reminder. So c squared equals a squared plus b squared minus 2 times ab, but this time it's cosine of c. So it's going to correspond with the c angle of c, angle of vertex c. Yeah. So we're going to be needing length of side A, side B, and of course your degree measure of angle C. So we have side A, we'll label this as 12. Side C, we'll label this as 7. And cosine of C is going to be approximately 60 degrees. So let's plug that into our equation. So c squared equals a squared, which is 12 squared plus 7 squared minus 2, put the 2 inside the parentheses, minus 2 times 12 times 7 multiplied by cosine of c, which is 60. Okay, c squared equals 144 plus 49 minus 2 times 7 times 12 is 84 times the cosine of 60, and then c squared equals 144 plus 49. So we have 140 plus 40 is 180. 9 plus 4 is 13. 180 plus 13 is 193. 193 minus 2 times 84. So 2 times 80 is 160. 2 times 4 is going to be 8. So it's going to be minus 168 times the cosine of 60. And then c squared equals, so 193 minus 168, you're going to add 168, 2 to 168, so that's 2 to 170, and then that's going to be 25. So it's going to be 25 times our cosine of 60 degrees, and then we're going to square root both sides. And once you plug that into your calculator, you're going to get that c is approximately 3.5. I'm rounding these off to the nearest tenth, so 3.5. All right, now let's look at a comparison of the two formulas of focus, which was inclusive of our our law of sines and our law of cosines. So it's law of cosines versus law of sines. So in order to solve an oblique triangle, at least one side and any other two parts are needed, of course. Like I showed you before, if you're looking for a side length, you need at least at least two sides, at least two other parts. But in this case, for law of cosines, you need your given angle, and then of course your two other side lengths. So the sine function is easier for side lengths in an opposite angle, because keep in mind your sine function, if you relate it to your right triangle, is going to be opposite over hypotenuse. So obviously it's going to be much easier if you have your given angle and then an opposite side length being utilized. And this is of course your triangle here, in which, say for example, you have your given angle A. It's much easier to calculate the side A as well. However, cosine is more, but it's utilized for side lengths and included angles. Keep in mind, it's utilized for your adjacent over hypotenuse. It's going to be adjacent sides that are going to be inclusive of that given angle. It's your included angle, such as B and sides B and C containing angle A. Much easier to use cosine, but it's just a lot longer. But for those specific circumstances, you should utilize it. All right, everyone. So that'll be it for today's video. This has been the eCoreAcademy e-learning platform. Please make sure to like and subscribe down below. Hit that post notification bell so you don't miss out on any of our channel's latest uploads. And please make sure to leave a comment down below if you'd like for any comments or feedback on what we're doing here. Also, visit our website at www.ecoreacademy.org. Reach out to us through our email at eCoreAcademy@gmail.com about any questions, say for example like our website. But I'll clarify now, our website is completely free. You just have to make an account there. Once you do, you have full unlocked access to worksheets, note sheets, integrated quizzes that go along with all of our videos and under their own subjects. And finally, visit all of our socials. The link is in the description down below for all three, at Facebook, Twitter, and Instagram. See what kind of content we have there and use all of our mediums to share all of our videos. Once again, everyone, that'll be it for today's video. I hope you guys enjoyed. I had a blast making this video. This has been AJ, and I'll see you guys in the next one. Peace.